At the heart of clouds are ice crystals. And at the heart of ice crystals, often, are aerosol particles. Dust in the atmosphere onto which ice can form more easily than in the open air. It's a bit mysterious how this happens, though, because ice crystals are orderly structures of molecules, while aerosols are often disorganized chunks. New research by Valeria Molinero, Distinguished Professor of Chemistry, and Atanu K. Metya, now at the Indian Institute of Technology Patna, shows how crystals of organic molecules, a common component of aerosols, can get the job done. The story is more than that, though. It's a throwback to Cold War-era cloud seeding research and an investigation into a peculiar memory effect that sees ice form more readily on these crystals the second time around. The research, funded by the Air Force Office of Scientific Research, is published in the Journal of the American Chemical Society. Throwback to cloud seeding. Molinero's research is focused on how ice forms, particularly the process of nucleation, which is the beginning of ice crystal formation. Under the right conditions, water molecules can nucleate ice on their own. But often some other material, called a nucleant, can help the process along. After several studies on the ways that proteins can help form ice, Molinero and Metya turned their attention to organic ice nucleants. As used here, organic means organic compounds containing carbon, because they are similar to the ice-producing proteins and are found in airborne aerosols. But a review of the scientific literature found that the papers discussing ice nucleation by organic compounds came from the 1950s and 1960s. With very little follow-up work after that until very recently. That made me really curious, Molinero says, because there is a lot of interest now on organic aerosols and whether and how they promote the formation of ice in clouds, but all this new literature seemed dissociated from these early fundamental studies of organic ice nucleants. Additional Res. Scientists explored the properties of organic compounds as ice nucleants to see if they might be cost-effective alternatives to silver iodide. But cloud seeding research collapsed in the 1970s after political pressures and fears of weather modification led to a ban on the practice in warfare. Funding and interest in organic ice nucleants dried up until recently, when climate research spurred a renewed interest in the chemistry of ice formation in the atmosphere. There has been a growing interest in ice nucleation by organic aerosols in the last few years, but no connection to these old studies on organic crystals, Molinero says. So, I thought it was time to rescue them into the modern literature. Going all classic fluoroglucinol is one of the organic nucleants studied in the mid-20th century. It showed promise for controlling fog, but less for cloud seeding. Molinero and Metya revisited fluoroglucinol as it proved potent at ice nucleation in the lab. One question to answer is whether fluoroglucinol nucleates ice through classical or non-classical processes. When ice nucleates on its own, without any surfaces or other molecules, the only hurdle to overcome is forming a stable crystallite of ice, only about 500 molecules in size under some conditions, that other molecules can build on to grow an ice crystal. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.